Yeah. Okay. Hello, everyone. My name is Balu. I'm a full stack developer at Gray Scientific Labs. So today I'm going to talk to you guys regarding real-time apps, building real-time apps with server-side events in React.js. So just before I start, I would like to state that in all my years of coding and visiting hackathons and taking part in a lot of conferences, I've noticed that not many developers are familiar with server-side events or SSE for short. It kind of caught me off guard because whenever I think of building, some real-time applications, I always the first thing that I think is, okay, can I build it using server-side events? And if I can't, is when I go to some other methods. So it kind of caught me off guard when I found out not many developers are aware about what server-side events are and what a good alternative they are to something like WebSockets or something. Uh, for certain use cases. So with that out of the way, I'm just going to start with so when you look at any traditional front-end client application, right? One way all of us are accustomed to to receiving data from the server is by sending a simple HTTP request, a get or a post request to the server and getting a response back. Now, when you look at it in the lens of a real-time application, this would mean that you constantly send a request over and over and again, and you get a response back from the server. Now, I mean, yes, while this certainly will work, it is not it's not the most efficient way to do it because one, you're making too many network requests, and two, the response you get may be exactly the same as the response you received previously, and it may be exactly the same to what you will receive next. So when you look at certain use cases where where your data doesn't update as not as fast as you want, and so that way the response you get back might be the same for a lot of requests. So that is one disadvantage with the traditional polling method, which is just a simple HTTP request, right? One way we can overcome this is by using long polling, which is similar to polling. But the difference with long polling is that when the client makes a request to the server holds on to that request and does not send a response back until it is ready. So this may take a while. So once the server has the response ready, it sends the response back to the client, and then the client closes the connection, and then rinse and repeat. This is slightly better, but it still shares some of the shortcomings of polling. That is, you still need to for every time for a real time application, you're still making too many network connections. One thing I need to tell about long polling is that, as I mentioned, right, the server, the connection, once the client sends a request, the server does not send the response back immediately. It waits for a while, and then once it is ready, once the response is ready, it sends it to the actual client. We can set a timeout, beyond which just close the connection and try again. So that is long polling. And I know WebSockets, this is what most of us default to whenever we want to build any real-time application, right? This is what it's widely used. It's quite old actually. It's very well-defined framework with support in most browsers. So whenever we think of any real-time application, WebSockets is what we go to. And just to kind of give you a brief explanation on how WebSockets work, right? WebSockets is a bidirectional communication that happens between the client and the server. Basically, the clients, it establishes a connection with the server, and after after the TCP handshake occurs with the server, there is a persistent connection between the client and the server. And in this connection, the client can send data to the server and the server can send data to the client. So it's a bidirectional communication, and it by all means is pretty great. And WebSockets are great, and you must use them. I really encourage people who haven't worked with WebSockets to learn about them and build a project or two, because they truly are amazing things to build, and to know how to use them would be a invaluable asset. So WebSockets is a persistent connection between the client and the server, and it's bidirectional. Now coming to server side events. Now server side events are similar to it's kind of similar to WebSockets, but at the same time it's kind of similar to long polling as well. So it is somewhere right in between. So how server side events works in a nutshell is that the client sends a request to the server, and the server, on receiving the request, sends a response back. But what happens here is that the connection is not closed immediately. Like WebSockets, the connection between the client and the server is persistent, and the client can receive response after response after response from the server once the server sends something back. So when you look at it that way, server side events is kind of similar to WebSockets, but it is but it has one major difference that separates it from WebSockets. That is, in server side events, data transmission is unidirectional from server to client. Vice versa is not possible. Unlike in WebSockets, where the client is also capable of sending data back to the server, in server-side events, it is not possible to do that. And that's not that much of a problem, because depending upon your use case, this may or may not be a problem, right? And that's why you look at it, right? Server-side events are typically used in places like news feeds, notifications, simple games like chess, where you don't really need client to server side communication. It's just receiving data. So when you look at it that way, server side events are extremely easy and extremely easy to use, and they're pretty good actually. And you'll understand why server side events are useful, and you should use them as you look at other aspects of it, which I'll explain on. So one of the beauty with server side events is that they can be implemented in any framework, right? So if you look at any framework like Flask or Node Express or Node.js or Python or Ruby or Golang or something, the only thing you need to do in the server end is basically set these three parameters in the header. That's basically set the content type to a stream, a text stream, the cache control, no cache, and connection keep alive. Why we do this is because server-side events, the response that is received back from the server is a text file. It's basically a text file. So that is why the content type has to be set to this in order to receive this. And it is extremely easy to set this in in Python, Node.js, or Ruby, or Go, or anything. You just need to set these in the header, and the response that is sent back has to follow this particular format. Now, if you do these two things, you can you can establish an SSE sub, an SSE server. Now if you look at this message format, which is basically how the response is going to look like. You see it has three parts to it: an ID, an event, and a data. Now you don't need to send an ID and an event all the time, and I'll get to why, and I'll get to why you need to send those eventually. For all, if you're just looking at something very simple, you can just send data, and in data you can send any text file, you can send a JSON, you can send anything there, and that's pretty much it. So it's this simple. It's just two steps to build a simple SSE server. Now coming back to why you need ID and event, right? One of the beautiful things about server-side events is that the client automatically re-establishes the connection with the server if the connection is lost for any reason, right? And in such an event, if we want the data flow to seamlessly flow through, meaning we don't want to refresh the page, or we just want it to just continue even after disconnection and reconnection, we want the data stream to just continuously flow. ID is really useful there. And event is basically just like you can, just like in sockets, where you can have different you can have different, like depending upon what the server emits, you can have you can have a set response in the client end. Similar to that, even in server-side events, you can have an event, and depending upon the event that is sent in the response, you can have the front end, the client side, perform a particular action. So this is an example of how a simple request may be like, right? Where you have you can have just ID is just a random number and the event, and in the data you can see there's a JSON object there. One important thing to notice is that at the end of the request, you can see there are two new line characters, escape characters, the backslash and backslash, right? Now the backslash n, the two backslash n's basically tell the client app that this is the end of the response, and because of that, it is extremely important that they are present in the server as well. So this is like, very simple. This is how simple it is to set up a simple SSE stream in Flask, right? It's just like 4 or 5 lines of code, and you can have you can set up an SSE endpoint in your API. And for those of us for Node.js fans, this is how simple it is. And like I mentioned before, right, the only thing you need to do is just set the content type. You just need to set the 3 parameters in the header, that is connection, content type, cache control, to the things to those 3 things, and that's pretty much it. And then your response has to follow the message format as I mentioned before. And if these 2 things are taken care of, that's pretty much it. That's pretty much all you need to do to establish, server-side events in your server. Whereas, if you look at like WebSockets, it's a bit, there's a little bit more, setup that needs to be done. So, and in the client end, it's literally this simple. You just set up a new event source, and then you listen to events from the stream, and depending upon the event type, you perform a particular action on it. So it's literally this simple to have SSE setup. So yeah, so I'll just very quickly move on to the demo. I would like to share my Kiran. I would like to share my camera. Yeah. Hey guys. So for the demo, I built a very simple. I've built this very simple application that receives data from a sensor basically, and it displays the values in a React web application. So I built this very simple. It's a very simple sensor circuit that just reads data from this humidity sensor and this light sensor here, and it uploads it to a MongoDB instance that I'm running locally. Okay. Yeah. So here you can. So okay, let me stop my video. Yeah, is my screen visible? Yeah. So my screen is visible, right?
Yes.
Yeah. All right. So if you guys can see my screen right now, you can see that there's it's a very simple demo that what it does is it receives data from the server, 3 sensors basically, a simple light sensor, air temperature, head humidity sensor, and it displays the values in real time here. Now, one thing you need to know is that I've added a delay in the sensor end. I've added a 5-second delay. That means every 5 seconds it updates a value. So it updates a value to the MongoDB in the MongoDB database, and then I read that value and I just display it here. So what I'm going to do is I'm just going to very quickly shine a torch in the light sensor, and you'll see that after a small delay, you see the value almost instantly goes up, right? And so this is and if I were to explain the code to you, right? So it's literally, so this is a very simple a Flask API that I have that has 2 endpoints. One endpoint to receive data from the sensor and just save it in the database, and the other endpoint is the actual meat of the whole operation here. So what it does is we have a function that is on a loop, and what it does is it reads data from the MongoDB database that I have running locally, and it just appends it to a to an array, and just sends it, right? It's nothing more. It's literally this simple, guys. In the server end, to just have to set up a server side stream going on, and in the front end as well. Now, one thing you need to mention, one beautiful thing about server side events is most browsers except Internet Explorer support it, and who uses Internet Explorer these days? So almost all browsers support server side events natively, and I'm not using any external API or anything. I'm just using the inbuilt event source API that is available to me, and all I'm doing is I'm just setting up a is it visible? Yeah. So all I'm doing is I'm just setting up a simple stream here, and then I'm listening to events on message, on error. What happens is once the connection is established, I pass the JSON, because as I mentioned before, right? The response is a text file basically in server side event. So I pass it back into a JSON, and I just set a hook to that value, and that value I send it to these components that basically display the data you see here. It's literally this simple, guys. And the code for both the server and client side applications are in my GitHub, which the link will be posted in the chat, so you guys can take a look at that. And it's literally this simple. Now, if you remember one thing, if you remember my presentation, you can see that there's this ID, event, and data here. Basically, this is so the demo I showed right now. There is no it's just sending data. It's not sending anything else. But what I can do is I can I can have a very simple I can just have very simple endpoint app.route, where I can show you how I can get that event thing to work as well. So I'll just have a simple stream 2. You have to excuse me for this for the namings. Let's go stream 2. So yeah. So what I'm doing here is basically I'm just response is equal to, I'm just just getting a random value. Random. I'm just response just random value between 0 to 100, and what I'm doing is that I'm printing it out here, right? So time dot cell, and then there's a small I'm waiting for 3 seconds. So in order to have so response, it's just a simple number, so I don't need to do something. So one thing I can do is I can set an event to it. I can call the event I don't know user stream, and I /n, and then ID can be can I don't know, it can be response again, then /n. So here if you look at stream 2. So if you look at this particular stream endpoint as compared to this here, you can see that I'm only sending the data. That is the sensor thing. In this case, what I'm doing is I'm sending an event, that event of user stream, an ID of response, and the data, the actual data, which in this case is just some random number between 0 and 100. So let me just restart the server.
Balu?
Yes.
One question we have is, can you show the network tab in the browser and show how the requests are going?
Sure. Oh, I need the So I'm just waiting for this to happen. Okay. Yeah. Run into a small video. Just 1 second. Perfect. Connection, waiting to connect to server. Right. The view function did not return a response. The function either returned none or ended without a return statement. All right. Okay. So seems to be an issue here. All right. So show that later. Something seems to be something wrong with that. Excuse me, guys. There just seems to be a small issue in the server side. Is my thing running? Yes, it is. Terms.
So are you returning the response in that new function?
Yeah, so I've run into a small issue in the server side. Okay. So as soon as I get it running, I will show to you guys. I'm unable to connect to the server. Response time.sleep. Yeah, back. All right. So here you can see in the network tab that you see that so you can see stream that the connection is established, but it's not closed. It keeps going. The connection is established, and the server constantly receives data from the server, and as I mentioned before, right, the connection is persistent. The server can send data to the client, but the reverse is not possible. There are ways in which you can do that, but I wouldn't really recommend So just to kind of show you, this is real time. I'll just shine a simple torch on the light, and you can see the values changing. So there is one way in which you can send data from the client back to the server, but it's not ideal. That is, you can use query strings, and you can use query strings to send data from the front end to the server. And in the server you can read the query strings, and you can use that data to do whatever you want. But that approach it carries the problems query strings have. So you need to know that. And so yeah, guys, so that's pretty much it. You guys can reach out to me on Twitter. That's my, and I know you can email me, and that's my GitHub. So thank you guys, and yeah, that's my talk. If there are any questions, I'd be happy to take them.